Hey there, CJ Math students. Welcome to Notes 2.18. So we're going to go through a whole bunch of mental math strategies. So strategy, first one, rearrangement or the commutative property. So basically, commutative property says I can rearrange multiplication and addition in any order I want to find products or sums. So let's do, instead of 8 times 7 then times 5, let's do 8 times 5 then times 7, because 8 times 5 I know is 40. And then 40 times 7, I just do 7 times 4, which is 28, and add a 0, 280. You guys try this one. The next one, multiplying by multiples of 10. Remember, we've been doing this all week long. When you do 70 times 80, basically just do 7 times 8 first, which is 56, and then count how many zeros you have, 1, 2, so therefore you add 2 zeros, 5,600. You guys do that one. Multiplication strategies such as doubles, or like when you have 12.5 times 4. Well, you know 12.5 times 2 would be 25, right? So then 12.5 times 4, or just times 2 more, should be 50, right? So for here, for this 16 times 25, if you think really carefully, you know that 25 times 8, you know this, right? Because think about quarters, right? 25 times 4 is 100. So 25 times, you can almost break this down, 20 times 5 times 4 is 100. So 25 times 8 would be 200. And then so therefore 25 times 16, or times 2 more, right, is 8 times 2 is 16, would be 400, right? So you can use benchmarks that you already know. Partial products for 4 times 15, right? You can say, I know what 4 times 10 is, which is 40. I know what 4 times 5 is, which is 20. And those added together, 40 plus 20, give me my answer of 60. You guys do that one. Swooping the decimal with base 10 facts. We've been doing this all week. We haven't been doing dividing. So for multiplying, right, you're going to swoop right. Swoop right. You're going to make the number bigger, right, by how many decimals you have. And then for dividing, oops, spelling dividing wrong. Dividing, you swoop left, make the number smaller, right? So let's try this. So 24,000 divided by 10, 24,000, 1, 2, 3, divided by 10. It means I only have 1 0, so I swoop 1 time to the left. So 24,000 divided by 10 becomes 2,400. You could even say 0.0 if you want to know where the decimal went. 24,000 divided by 100. So I have 2 decimals, 1, 2, so that means I'll swoop twice, once, twice. So that is equal to 240.00, or just 240, right? 24,000 divided by 1,000. Oops, I messed up, sorry. I meant to do that in black. So 3 decimals, 1, 2, 3. So swoop 3 times, 1, 2, 3. So 24,000 divided by 1,000 obviously equals 24.00, or 0.000, however you want to say it, or you're just 24, right? Now it's the same thing for multiplying, right? 2.4 times 10, except we're going to swoop right. You have 1 0 equals 24, right? 0.24 times 100. Notice how the decimal changed, right? It moved in front of the 2 once, twice. So 0.24 times 100 also equals 24. Think about why that's the case, right? When we multiplied by 2.4, we were just multiplying it by 10, right? When we multiplied by 0.24, we're multiplying by 100th. This 4 is in the 100th spot, so multiplying by 100th, we'll bump it to the 1 spot. This 4 is in the 10th spot, so multiplying by 10, we'll bump it to the 1 spot, right? So this 4 is in the thousands place. We're multiplying by 1,000. What do you think is going to happen? Yeah, it's going to bump it to the thousands, or to the 1 spot, just like we did the last one. So 0.024. We have 3 zeros, so 1, 2, 3. So again, that equals 24. Right? Now, if I were just to take 2.4 and multiply it by 100, I just want to show you the difference. 2.4 times 100, not 0.24. We'd swoop 2 times, 1, 2, and that would equal 240. So just you can see the difference. It's not always just the number stays the same, right? They were trying to show you how the number gets larger, or sorry, when you multiply by bigger base 10s but smaller decimals, how it stays the same. For the next mental math strategy, when you're dividing by 0.01, it's the same thing as multiplying by 10. So basically you want to count all numbers behind the decimal. So for here, 0.024 divided by 0.01, we have 2 numbers behind the decimal, and we're going to swoop right on this one. When we're dividing by a number smaller than 1, we actually swoop right. So this is interesting. Unless smaller than 1, swoop right. Okay, so here, we're going to take this, we're going to swoop right, because there's 2 numbers behind the decimal, once, twice. All right, so this is equal to 2.4, right? Same thing here. 4.3 divided by 0.001. We have how many numbers behind the decimal? 1, 2, 3. So that means I'm going to swoop 3 times. So if I write out 4.3 again, 4.3, swoop 3 times. Because this number's less than 1, I'm swooping to the right. 1, 2, 3. You got 2 empty spaces I got to fill in with zeros. So this equals 4, 3, and then 0, 0, right? So 4,300. Okay, let's flip over the back side. So on the back side, you're going to practice a lot of this. I'm going to do probably one problem in all of them, just to kind of help you out. So for this one, when you're multiplying just a whole number in a decimal, literally just ignore decimal until the end, right? So ignore the decimal until the end, and then just count your decimals, right? So 6 times 2, that's 12. I have 1 decimal place, so 1.2, right? 7 times 4, that's 28. I have 1 decimal place, so 2.8. 8 times 5, 40. I have 1 decimal place, so 4.0, right? Now, when we're multiplying decimals and base 10, you're just, just like we've been doing, count the amount of zeros you have. So 2.36, swoop once to the right, equals 23.6. 0.34, I have 2 zeros, so swoop twice to the right, 1, 2, equals 34. All right, 46 times 10, I have no decimal, but I have 1 0, right? So swoop right to the ones, so 460. Okay. For here, you just want to do some rounding. I'll do one of these with you, and then you'll do the rest. So 22 plus 51, you just want to use mental math, right? So 22 rounds to 20, 51 rounds to 50. So 20 plus 50 is about approximately 70, right? 22 plus 51 would be actually 73, but we're just approximating, right? Same thing when you're multiplying, right? 21 times 29, right? It's 20 times 30, so approximately it's about 2 times 3 plus 2 zeros, 600, right? You're doing the ones that I'm not doing. Again, when you're talking about money, right? $1.78 rounds up to $2, plus $2.99 rounds up to $3, and 84 cents rounds to about $1. So 2 plus 3 plus 1 is about $6, right? Now these last ones, sorry about that. These last ones, again, you're going to want to round and try and get a percentage out of it. So 24 out of 99, right? So really we could say, okay, what benchmarks do we actually know? We know that 24 is pretty close to 25 and 99 is pretty close to 100. So 24 out of 99 is pretty close to saying like 25 out of 100. And obviously we know that is 25%, right? Same thing with 12% out of 400. Well, 12%, what benchmark is it close to? It's close to 10%. And 10% of 400, right, or 0.10 times 400. Remember, when it's smaller, you're doing the opposite. So when it's smaller than 1, I have 1 0. I'm not swooping to the right, I'm swooping to the left. So it's about 40, okay? 19 out of 80. This is like almost saying like 20 out of 80, right? 20 out of 80. And then if you really simplify this down, you can divide them both by 20. It's like 1/4. And since that's like 1/4, hopefully you know what that percentage is, right? So you're trying to use different benchmarks. So again, if it's 11% out of 80, maybe you want to do 10% out of 80, right? 29 out of 50, maybe you want to do 30 out of 50, right? 194% of 40, maybe you want to do 200% of 40, right? So you're trying to use different benchmarks, okay?